In this video, I am going to explain the difference between a scalar quantity and a vector quantity. The best way to illustrate is by doing this. Let's begin by creating a coordinate system. Of course, you're free to create your coordinate system as you like, beginning anywhere essentially. So I will make a little coordinate system over here. This will be our y-axis. This is the x-axis. Here we are. And now say the following occurs. A little person perhaps starts out at this point, at the origin, and goes meandering about, taking a path that looks like this, and then stopping right here. Okay? What you see is the actual path taken by the little person, okay? So the little person is first here, and then the little person walks along, and then maybe this person is over here, and then walks along. And imagine perhaps we are seeing this from above, okay? And then the person continues to walk or run, get some exercise, what have you, and then this person stops right here. This is the path of the person, as you can see. This is a scalar quantity. In this specific case, you would describe this scalar quantity as the distance. Okay? So the actual distance traced by the person as this person walks along some path is known as the distance, a scalar quantity. There is no implication of direction of any kind. As you can see, this is a very meandering path. Sometimes it's going this way, sometimes that way. There's no implication of direction. So now what we will do is introduce the displacement vector and differentiate between distance and displacement. And that then will allow us in a very visual way to see the difference between a scalar quantity and a vector quantity. So what would be the displacement vector in this situation? That vector would simply go from the starting point to the ending point like this. Okay, we draw an arrow that looks like this. This is the displacement vector. It's the straight line distance from the starting to the ending points, ignoring anything that happens along the way. Okay? So what I will do now is create a new coordinate system, and we will magnify things to make them easier to see and depict. So this is our x and this is our y. This is the original picture. And now I'll reproduce this, but make it thicker and easier to see. So imagine the displacement vector is this quantity right here. Okay? And the path taken by the person does something like this. Okay? So as before, you're imagining the person starting here, and this person runs along the track now. And then keeps running along the track. Okay, you see how my hand is moving along the curve? This is the distance. I am tracing the distance, and then we end up over here. Okay? The displacement vector is the black arrow. It's simply the straight line from our starting point to the ending point. So it has both a direction, in other words, take a look. The displacement vector has an angle that it makes with respect to the x-axis. We will call that angle theta. It has an angle that it makes with respect to the x-axis. Right there. And it's got a length. We'll call that L. So this is a vector quantity. It's got an angle and a magnitude, or a length, if you like, or a size. Whereas a scalar quantity, such as the distance, has no direction but only a size. In this case, the length of the little path that I am tracing with my fingers. There you go. And the displacement tells us the following. As a person, I have this choice. I can take this long roundabout path and reach this point here, or instead what I can do is simply follow the displacement vector and reach the same point. Okay, that is what it is that it allows us to say. I can go from here, so to speak, and I can simply follow this path and reach this point, just as this person here reached that point by taking this roundabout indirect route. Okay, so a scalar has only a magnitude, or a length, if you like, a size, but a vector has a size, a length, or a magnitude, and an angle that it makes with respect to the x-axis. So it's also sometimes known as a directed line segment. There you go. Thank you for watching.